Okay, hi, welcome. We're going to start in just a minute. We're just waiting for a few more people to get online. In the meantime, if you have questions during the presentation, you can put them, you can submit them through the chat. Down below, you have a chat option. You can submit your questions through the chat. You can address one of the panelists, and we will answer your questions at the end of the presentation. Okay, so welcome to All Cloud's webinar on how to triple your speed of development using automation. Our presenter today is Johanan Liebermann. He's All Cloud's automation expert. Just a few words about All Cloud. We're an AWS Premier Consulting Partner, as well as a channel reseller and managed service partner. If you have any questions about your cloud environment, we are your trusted advisor for your cloud journey. If you're interested in starting your DevOps career, you can also send your resume to us at info@allcloud.io. You'll see a slide at the end of the presentation with our email. And like I said, if you have any questions, you can submit them through the chat and we will address them after the presentation. So let's get started.
So hi, everybody, and thank you for joining us. My name is Johanan Liebermann, and I'm a software developer at All Cloud. So here is our agenda for today. We're going to start with a short introduction. Then we will see how we can use automation to speed up your development and your software release cycle. Then we will look at two real use cases, one for Docker-based workloads and one for instance-based workloads. And we will finish the webinar with a live demo. So today's software world moves really fast. If in the past you needed a very big team of developers in order to ship a big product, then today it's not the case anymore. So today tiny startups can challenge very big companies, and the internet has changed all of that. Delivering your product to the masses is very easy today and very quick. And if in the past a software release cycle was measured in weeks or even months, then today it could even be days. Time to market can literally make or break your product. So you have to remember that even if you have the shiniest and newest features, your competitors probably deliver their products quickly. So sometimes this is the deciding factor for the success of your product. So how can you move faster in order to keep up with the pace of today's software world? The answer is by using automation whenever possible. So let's start with a couple of important terms. Now, please forgive the buzzwords. I swear these are real things. So you're probably familiar with the term DevOps. There are many definitions to DevOps. Here is mine. DevOps is a set of practices which make software lifecycle more efficient by bridging the historical gap between development and operations and aiming for automation in every aspect. Now, CI/CD is a major part of DevOps, and in order to utilize it, you have to automate things. So CI/CD stands for continuous integration and continuous delivery or deployment. And it is, like I said, a major part of DevOps. Now, in CI/CD, when you use CI/CD, you're basically creating a pipeline for delivering your software to your customers. And you do this by continually building, testing, and deploying your code in very short iterations. Now, if you do this, it allows you to catch problems as soon as possible, which is very valuable as a developer. And it allows you to work on multiple features easily in parallel without one developer interrupting another. And as already said, when you use CI/CD, you ship code often and in very small chunks. Now, the term cloud native applications isn't directly related to automation, but I still would like to mention it here because it is much easier to achieve CI/CD for applications that were built following these principles. So there are many attributes to cloud-native applications. Here are a few important ones. They are usually stateless, which means it is easier to scale, and they are typically more resilient to failures if they're stateless applications. Cloud-native apps are usually broken into microservices, which means it is easier to put them into containers. Sometimes they could be serverless, and if your application is serverless, it allows you to utilize the highest level of infrastructure abstraction, whether it's Lambda in AWS or Google Functions or an equivalent. And cloud-native applications also utilize managed services whenever possible, because this is what allows you to leverage the full potential of the cloud. I highly recommend taking a look at 12factor.net. This is a website that was created by very smart people, and it outlines 12 principles that when followed, your application can be very close to cloud native or completely cloud native. So take a look at it. Now, what areas can we automate? So today, we are lucky enough to be able to automate everything from code to production. Now, most of our customers utilize automation in some of these areas, but not in all of them. Now, if this is your case, you can probably save valuable time by completing your software delivery pipeline so that it is fully automated. So you can automate in every area, starting at version control and ending at the deployment and release if you're brave. Let's start with version control. Version control is managing changes to source code in a simple form. Now, how can you use automation in version control? One thing that is commonly overlooked is Git hooks. Now, of course, you can use Git hooks in order to trigger your CI/CD pipeline. This is well known. But you could also do lots of other useful stuff using Git hooks. For example, you could enforce your code style by either blocking commits that don't adhere to your standards, or automatically changing stuff when necessary. So for example, let's say that you have a Python project and you want to make sure that the indentation is done using spaces and not using tabs. If you use Git hooks, then you could say, okay, you cannot commit code that is indented using tabs. Or you could automatically convert tabs to spaces when somebody pushes a new commit. Another thing that could be very useful is automating the handling of pull requests. So for example, let's say that somebody has opened a pull request for your repository. Now, if the code in that pull request doesn't compile, there is no reason to bother your developers with it. So you could just as well automatically build the code that was pushed in this pull request, and then if the compilation fails, automatically insert a comment using your Git provider's API to say, okay, this pull request doesn't build, so you should add new commits to fix it. Now let's talk about build process. This is a very major part of CI/CD. The build process means generating artifacts from your source code. Now, how can you use automation in your build process? There are many build automation tools that are very well known. So stuff like Make, Maven, Gradle. Now these tend to be technology specific or language specific, but not always. So for example, Make can do all sorts of stuff, and Maven can also build stuff that's not only Java, for example. And another very important thing is dependency management. Now, there are dedicated package managers like pip or npm, but there are also tools that do both build automation and package management. So this is a case. This is the case with Maven, for example. Maven can not only build your source, but also handle dependencies for you. So you should definitely use both build automation tools and package management tools for dependency management. Now, the dependency management is very important, not only as a good software development practice, but also it makes build automation a lot easier when your dependencies are handled automatically. Now, what do you do with the artifacts that your build process generates? Your artifacts should be properly versioned, and they should be stored in an artifact storage solution that is consistently available. What does this mean? It means that if my code depends on a library at a specific version, for example, 1.2, then when I include this as a dependency, I should first of all get the artifact, and second, I should get the correct artifact from the artifact store. Now, there are multiple types of artifacts. Some of them are language specific, like jar or gem. Some of them are OS specific, like RPM deb or APK and IPA for mobile artifacts. And some of them are images. So for example, an EC2 AMI is considered an artifact if you're using Immutable Infrastructure, for example. And same goes for Docker images. So these are all artifacts that should be properly versioned and consistently available. Now, where do you store your artifacts? So that depends. There are kind of all-in-one solutions like Artifactory or Nexus that can store all sorts of artifacts, but there are some that are more technology-specific, like ECR or Docker Hub, that are dedicated for Docker images. So there is no one rule here. It really depends on your case. And you could also use, traditional file storage like AWS S3 for storing your artifacts. However, if you do this and you have no third-party tool for managing the versions, it could be a little tricky because all S3 does is store files. Testing. Testing means verifying the quality of your code. Now, there are many types of testing, which you can use throughout your software delivery lifecycle. We will not go through all of them. We'll just mention the most important ones. So we have unit testing, integration testing, and functional testing. Now, unit testing may be the most common type of testing, and definitely the one you should use the most often. Now, unit testing means making sure that a small isolated chunk of code works properly without any external dependencies, databases, etc. And typically, unit testing is done as part of the build process, and it should be perceived as an integral part of your code and of your build process. What does this mean? It means that if you're building your code automatically and you have a failed unit test, you should not generate an artifact and continue down the pipeline because you'll have a problem possibly in production. Typically, unit testing is done using built-in language features or dedicated frameworks. So there is JUnit for Java, there is PyTest for Python, RSpec for Ruby. These are just a few examples. And again, the main advantage of using unit tests is the developer gets a very fast feedback for code changes. So you don't need to wait for a heavy integration test or functional test to end before you know something went wrong. But of course, unit tests are not always as comprehensive as the other types of tests. Now, integration testing means that making sure a couple of components work properly together. And it should be done as part of the deployment and release process, mainly because usually integration testing requires a live environment, a working environment, in order to run. There are tools for there are dedicated tools for integration testing, but many of our customers use custom code for this purpose. And integration testing typically involves external entities, such as databases, third-party APIs, etc. Now, the difference between integration testing and unit testing isn't always clear, but this is the best distinction or the most commonly used one. So if your test includes a database or requires a database, it is not a unit test, it is an integration test. The last type of testing we'll talk about is functional testing. And this is obviously the costliest kind of testing. This means end-to-end testing of your product. And it should be done as part of your deployment and release process. Now, functional testing, the actual nature of the testing depends on the type of application. So typically with front-end application, you simulate user interactions using tools such as Selenium or Appium. And for backend services, you typically simulate API calls using tools such as Ready API. Now let's talk about configuration management. Configuration management is a term that means ensuring your servers are properly configured to serve your application. What does this include? Usually things like installing OS-level packages or language-specific packages, ensuring that configuration files are in the desired state, maybe changing file permissions, setting environment variables, making sure the correct services are up or down, all this kind of stuff. Now, typically, most dedicated configuration management tools they use declarative syntax, and they're idempotent. Now, declarative syntax means you're telling what you want to happen. You're not saying how to do that. So you're basically specifying the desired result, and the tool takes care of how to do that. Idempotent means that you can run the same operation 1 time or 10 times, and you'll have the same result. Here are some examples of configuration management tools. So we have dedicated tools, like we said, things like Ansible, Chef, Puppet, or Salt. And sometimes you get configuration management as a byproduct. For example, if you use Docker. So one of the big advantages of using Docker is that you don't need to worry about configuration management anymore because it is done as part of Docker. Another example is ebextensions. If you're familiar with AWS Elastic Beanstalk, then you get a limited form of configuration management just by using Beanstalk. And you could use custom scripts. However, from our experience, it is not recommended since it tends to be extremely difficult to think about all the edge cases when you imperatively type a script or write a script to do configuration management. Now, there is this notion of mutable versus immutable infrastructure. There are 2 approaches to managing your infrastructure, and I want to mention them here because it is important to be aware of them. Mutable infrastructure is when you modify your existing nodes. Now, the node could be a server, it could be a container, it doesn't really matter. Immutable infrastructure means you don't touch existing stuff, you only delete old stuff and create new stuff. So you're basically replacing your nodes rather than modifying them. Both options are achievable when you use configuration management tools. How? Typically, configuration management tools follow the mutable infrastructure approach because they directly manage and change your nodes. Now, you could also use configuration management tools to generate images. And if you do that, you're basically following the immutable infrastructure approach because you're generating a new image using Ansible, for example, or Chef. And then you take this image and you roll out a replacement of your existing nodes from the new image. So both approaches work with configuration management tools. Let's talk about infrastructure provisioning. Infrastructure provisioning is the idea of creating, updating, and destroying your cloud infrastructure. Now, this is an area in which a lot of our customers don't use automation for some reason, even though it is one of the most time-consuming areas in your software delivery pipeline. So I highly recommend completing your pipeline if today you're not using infrastructure provisioning using automation. This is relevant mainly for infrastructure as a service providers, because if you're using platform as a service, typically the infrastructure is not under your responsibility. Now, what resources do you typically need to provision? First of all, things like compute resources. So this could be EC2 instances, ECS clusters, Lambda functions, etc. Networking and security. This is something a lot of customers overlook. They say, okay, I will create my instances automatically, but what about the network and what about the database, for example? As we said, database caches and anything that handles data, and also file storage solutions or block storage solutions. And finally, things like IAM permissions, policies, SNS, SES for sending emails, monitoring. These are all part of infrastructure provisioning, and these are things that are not directly related to your code, but still need to happen. Now, infrastructure as code is an interesting thing. It's a relatively new approach that says that infrastructure equals code. Now, what does it mean that it equals code? It means that your infrastructure must be version controlled, tested, and you can collaborate upon it the same way as you would with your product's code. Now, if you use infrastructure as code, it gives you very good reproducibility because you define a template once, usually in a declarative and idempotent way, like we said about configuration management, and then you can just deploy it everywhere from that template. So it creates very good reproducibility for environments. It also allows you to create very similar dev, staging, and production environments from the same template. You're just changing a couple of variables. Let's talk about 2 examples for tools that give you infrastructure provisioning. One of them is CloudFormation, which is the AWS offering for infrastructure as code. And the other is Terraform, which is an open source equivalent, a very good one by HashiCorp. Now, similarly to configuration management, sometimes you get infrastructure provisioning as a built-in functionality. Like I said, if you're using a PaaS solution, a platform as a service solution like Elastic Beanstalk or Heroku, then the infrastructure is already managed for you. You probably don't need to worry about it. Finally, let's talk about deployment and release. Deployment and release means making your code available to your users. Now, the deployment process varies based on type of application. So if your application or service is a backend service, then you typically deploy by updating or replacing instances, containers, or Lambda functions. And sometimes, if your database is an SQL database, you probably need to run database migrations too. Now, if the service is a front-end service, usually you run tasks like minification for your CSS, HTML, and JavaScript. Maybe you need to run a CSS preprocessor and prepare a source bundle for deployment. Then you sync these static files to some either an S3 bucket or an equivalent. And finally, if you're using CDN, which you should, then you probably need to invalidate it in order to make sure that the older version is deleted from the cache. Now, if your app is a mobile app, then you might need to sign the artifact before publishing it, and then you need to upload it to App Store or Google Play. All these parts can also be done automatically. So again, don't overlook this. This could be a bottleneck if your entire pipeline is automated except your deployment process. Now, deployment for backend services tends to be more complicated than other services, so I would like to very quickly mention a couple of strategies for deploying backend services. Now, you could run in-place update, which means simply updating or replacing your live nodes. This is not very recommended in some cases. However, if you do utilize in-place update, you should do it in a rolling update kind of way, so you don't replace all your live nodes at once. Now, canary deployment means deploying to a small number of servers first, or nodes first, making sure everything behaves properly, and only then replacing the entire mass. And finally, a very interesting technique called blue-green deployment. You might be familiar with it already. The idea is that you're maintaining two identical production environments. You are updating one of them, running. This is a good place to run your integration and functional tests. You make sure that everything works properly, and only then you do the cutoff. You switch over to the other environment. Now, let's look at a sample pipeline. Now, this pipeline follows the Mutable Infrastructure approach, and I chose to present AWS CodeDeploy as the base of the pipeline here. Now, CodeDeploy is a managed deployment service by AWS, and it handles the deployment process and just the deployment process for you. Now, it has built-in support for both in-place rolling updates and for blue-green deployment, and it manages the state of the deployment for you. So, for example, if you started the deployment and then it failed, it is able to stop and roll back the deployment and not continuing with a failed update. It also supports automated rollbacks or manual rollbacks, and is platform agnostic. So it is basically agent-based, and you can use it with all major OSs. Doesn't matter your language, your runtime, and your configuration management tools. CodeDeploy has native integration with other AWS services, most importantly, autoscaling and ELB. So for example, if you have a load balancer behind which your instances are running, it can automatically detach them from the load balancer prior to updating and then reattach them and making sure the health check works properly. And best of all, it's free. With a small remark, it is free if you use EC2. Now, it is possible to use CodeDeploy for on-premise workloads, but then it's not free. So if you use EC2, you can just use it as is. This is a sample pipeline we're going to look at. So we have a Go application, a web application that's running on Amazon Linux, and we have Jenkins as an automation server. I chose to store the artifacts on S3 and use Ansible for configuration management. And finally, CodeDeploy for orchestrating the deployment. So this is what the pipeline looks like. We have a developer that commits code to a Git repository. And we have Jenkins that checks out that code. Now, first of all, Jenkins runs unit tests in order to make sure that a valid artifact, a working artifact, can be generated from the code. So it just runs Go test, since it's a Go application. Then it builds the source, Go build. And here we generate RPMs. Why RPMs and not just one RPM? Because we're generating RPMs for both the application itself and the configuration management code that came with it in the same repository. So in our case, it generates 2 RPMs for the application itself and for Ansible code. And then it stores these RPMs in S3. Next, Jenkins will trigger or create a new revision on CodeDeploy, which basically notifies CodeDeploy that new code has been pushed, and then it triggers the deployment. From now on, Jenkins has finished its work, and CodeDeploy is taking care of the rest. So CodeDeploy will then deregister one instance or a couple of instances, depending on what you configured, from the load balancer. It will then install the Ansible RPM, and it will then run Ansible, which in turn will make sure that proper RPM for the code will be installed from your artifact storage, S3 in our case. Then finally, it will verify the service is running properly and then re-register or reattach the instance to the load balancer. So looks kind of complicated, but it's a very nice use case, a common one. We have many customers using this approach. Now let's look at another pipeline. And this one is a Docker-based pipeline. So ECS is the Docker offering or managed container offering from AWS. It stands for EC2 Container Service. And it runs on top of EC2. Now, ECS contains a built-in Docker register solution that's called ECR. But of course, you could also use Docker Hub or any alternative for storing the Docker images. It provides native integration with auto-scaling ELB and IAM. And it is free, except for ECR, which charges for the volume of Docker images that you're storing. Now for this pipeline, and by the way, this is the pipeline we will also have a live demo for. We have a Python web application that runs on Docker. We have still Jenkins as an automation server. We chose Jenkins simply because it is the most popular automation solution. We have ECR for storing the artifacts. There is no need for configuration management because Docker handles it. And finally, we have ECS for managing the actual deployment and running the application. Similar to the previous pipeline, once a developer commits new code or pushes new code, Jenkins identifies it, pulls the code. Now Jenkins builds a Docker image. Now here, if you noticed, the unit tests are run after generating the artifact. Why is that? Because Python doesn't require compilation. It is just plain text files. And it makes more sense to run the unit tests in the context of the container, the already built container, than to run it on Jenkins and only then generate the artifact. So here we reverse the order of things. Then after the unit tests pass, and only if they pass, we push the image to ECR. Then we update ECS that the new version has been pushed. And ECS replaces the containers on our cluster. Let's see this live. So this is our Jenkins. I'll need to relog in just a moment. Now, it's quite a simplistic build process. It is actually oversimplified just for demo purposes, so please don't take this as best practice. It is just for demonstration purposes. So basically here what we're doing is we're extracting the current version from the code itself, from the file that holds the version tag. Then we build a Docker image, like we said. We run the unit tests on inside a container on Jenkins. Then we tag the image for pushing to ECR, and then we push to ECR after getting the credentials for it. And finally, we set a new version in the ECS task definition file, and then we create a new task definition revision on ECS. And finally, we trigger the update. So I apologize if you're not familiar with ECS, or if this is too low level. I just wanted to show what the pipeline looks like before actually executing it. And this is our ECS cluster. So I basically just have one service that's called ECS app. Here is our app. It doesn't do much. It basically just shows the hostname of the container that's serving the app and a version. Now, at the moment, as you can see, we're on version 2.3. Let's say we want to upgrade to 2.4. This is our app. I'm updating the version. And pushing menu code. Now, that's it. So from now on, the entire process is automatic. And I can already go ahead and look at Jenkins to see if it already started the build. If not, then it could take it a couple more seconds because it is polling the repository every minute. So let's give it a moment. Now, we could have used the Git hook here in order to trigger the deployment, but that requires exposing Jenkins to the internet, which I just chose not to do in this case. But it is definitely an option. Yeah, so now the build is started. Seems like we just missed the previous interval. And we can see the process live in just a second. So it is currently scrolling pretty quickly. I will walk through the process more slowly in a bit. Right now we can see it already builds the Docker image. It just finished running the unit testing. It's now pushing to ECR. And it has finished updating ECS. So now, from this point, we should be able to see the update process happening on ECS. I'm not doing anything, I'm just watching. So these are currently running tasks or containers. We have 2 for this app. Now, this is the revision. It has nothing to do with 2.4 that we just specified for the software. This is just the ECS task definition revision. So it should be updated to 25 once ECS realizes it needs to update. So here you can see it just added 2 new containers, and then it will drain the old ones and detach them, or basically kill them, since it's Docker. Great. So I think that at this stage, we can already see the new version here. So let me refresh here. Yeah, we have 2.4, and we might still get, for a couple more seconds, the older version until it is properly drained. It's just a timer that you can tune. Give it a couple more seconds. Okay, all done. So I finished upgrading to version 2.4. And again, the whole process was automatic. Now let me walk through the process very quickly, and then I'll show you what happens when I push a bad commit. So we started by retrieving the code. Then, we retrieved the version, Docker build, created the image. I think there is no reason to walk through the whole process again, but you can see that everything that we just saw took place, including unit tests. Now, let me push a bad commit for a second to show that the pipeline will halt. It will not deploy to production because there is a problem. So I'm going to create a problem here. I'm going to return a wrong value. Forgive the commit message. We'll push it. And I will trigger the deployment manually this time, so we don't have to wait. Now, this time I expect the build process to fail, because the unit test will not pass, and then we will not push to ECR, and we'll definitely not deploy the new image. So it's still building the Docker image. And now, as you can see, it ran the unit test here, And since we had a failure, we expected to have 2.4, but instead we got 1.0. We're blocking the pipeline and not deploying. So typically now the developer or the committer will get a notification. So let's get back to the presentation. So to conclude, we suggest that you implement a fully automated pipeline to leverage the full potential of the cloud. If your pipeline is only partially automated, you're probably wasting valuable time. Now, we do suggest that you rely on managed services as much as possible, because it will reduce the manpower needed for operating your service, and it sometimes even indirectly reduces costs. And finally, using automation wherever possible will boost your speed of development and will allow you to focus on your differentiating factors, on what matters to you, rather than maintaining service. Any questions? So if you have any questions, please type them in the chat, and we'll do our best to answer all of them. Okay. So we have a question from JJ Yom. Looks quite complicated. Any shortcuts? So my best recommendation here is to use Docker wherever possible, because Docker tends to be much simpler than Docker pipelines tend to be much simpler, as you saw, than non-Dockerized pipelines. However, you could always utilize us for building your pipelines for you or to assist you in designing them. And eventually, yeah, the pipeline or the fully automated pipeline might look complicated, but in the long run, it saves you a lot of time. So you build it once and you use it all the time.
Okay, so Maria has a question. Is AWS ECS supporting Windows?
Yeah. To be honest, I'm not sure. I've never tried running Windows workloads on ECS. I can tell you that in general, the idea of running Windows containers is relatively new. And the main reason I personally don't use it is that just the base image for running Windows is over 5 gigabytes of storage. So it might be possible. To be honest, I'm not perfectly sure, but if there are problems there, they're probably Docker related more than ECS related. Also, ECS runs using an agent, and I don't think AWS has an ECS agent for Windows. So if you're talking about the host operating system rather than the container operating system, if you manage to get the ECS agent to work on Windows, then I don't see any reason why it shouldn't work, because Docker works on Windows, but it's emulated, and I would say not the best idea. So there's a question, what's your opinion on HashiCorp's suite of products with regards to CM? So HashiCorp, as far as I remember, they don't have a pure configuration management tool. However, they have Terraform, which is an infrastructure provisioning tool. So it's kind of similar, and it could work well with configuration management. So a possible combination of the two could be using Terraform to deploy your infrastructure, including your instances, and then triggering a configuration management run from Terraform which would use Ansible, Chef, or any other dedicated configuration management tool. So, for example, you could use, you could use Terraform to do configuration management, but the configuration management support in Terraform is quite limited. So I would use the right tool for the job there. Another thing is they have Packer, which is a tool that allows you to generate machine images for Docker, Vagrant, EC2, or whatever. And Packer is based on configuration management. So this is the example we talked about before, where you use, for example, Ansible, Chef, or Puppet to generate a machine image and then roll that image on your cloud infrastructure. So yeah, there is some possible collaborations or integrations between HashiCorp's products and CM, but they might not work well in all cases. So there is a question, what about multi-container services? So I'm not sure I understand what the question is. So I will answer in the context of ECS. You could definitely run multi-container workloads on ECS. And typically, if your application is broken down into smaller services, then each one of them will be served by a set of containers. Yeah, there are built-in solutions for that on AWS. So, for example, in the case of ECS, you will probably need to utilize service discovery, which means if service A needs to talk to service B, then it is done typically with an application load balancer or ALB. You could also use a solution like etcd or console for handling the service discovery and then updating Route 53 or any other DNS solution to discover your services. But it's more complicated and needs to be, you need to build it yourself. Is there a more specific question about multi-container services? Do we have any other questions?
Okay, so if you think of your questions later, then you could always email us at info@allcloud.io. Also, like I said, you can send us your resume if you're interested in a DevOps position. You can see our website. We have a careers page. You can see all of our open positions there. And feel free to contact us with any questions that you have about the cloud, AWS, and we will see you next time. Thank you.